Lesson 7.3 is solving systems using elimination. So we're still doing solving systems. However, this is a third way to solve them. This is using elimination. So the addition and subtraction properties of equality can be extended to state if A equals B and C equals D, then A plus C equals B plus D. So you can use the addition and subtraction properties of equality to solve a system by the elimination method. You can add or subtract equations to eliminate a variable. So now here's how it works. If you look at these two equations, okay, you notice that the 6y's, they're the same. One's negative and one's positive. So what you're going to do is you're going to eliminate them. And you're going to add these two together. And what you do is you line them up and you add down. So if I add 5x and 3x, I get 8x. Negative 6y plus 6y is 0. I bring down my equal sign. And then negative 32 and 48 equals a positive 16. Then I divide by 8, so x equals 2. This is my favorite way because it's so simple. And then now if x equals 2, I'm going to put 2 in for x into one of the equations to find out what y would be. So I just chose the top one. So 10 minus 6y equals negative 32. So you minus 10. So negative 6y equals negative 42. Divide by negative 6. So y equals 7. X is 2, y is 7. So try this one. All right, so I'm going to draw my line. And 6x minus 6x, those cancel each other out. Negative 3y and positive 5y is 2y. And then what you're doing is you're adding, remember, you're adding this whole thing. So 3 plus 3 is 6. So you divide by 2, so y equals 3. Then I'm going to do 6x minus 3y equals 3, and I'm going to put 3 in for y. So 6x minus 9 equals 3. Add 9 to both sides. So 6x equals 12, so x equals 2. Now, on your test, you're going to really want to make sure that you plug both of those numbers into both equations and they work. So 2 and 3. If I put 2 and 3 in, 6 times 2 is 12, minus 9, does that equal 3? Yes. Negative 6 times 2 is negative 12. Plus 15, does that equal 3? Yes. So they both work for both equations. Suppose your community center sells a total of 292 tickets for a basketball game. An adult ticket costs $3, a student ticket costs $1. The sponsors collect $470 in ticket sales. Write and solve a system to find the number of each type of ticket. So first of all, you have to realize that you sold 292 tickets. That's going to be your first equation. It's just going to be x plus y equals 292. So this is what they did. A plus S, adults plus students equals 292. And then they did the adult tickets $3 and the student tickets $1, and that equaled $470. So then they have a whole second equation. Next, they set these two equations into a system, and you're going to subtract them. Why they chose to subtract is because both of the s's are positive. So if I have both of them positive, see, we're back here in this last example. One x was negative and one was positive, so it was already done for me. However, here they're both positive. So what you do is you change the whole entire bottom row to negatives. So then you do a minus 3a is negative 2a, s minus s is 0, and 292 minus 470 is negative 178. Then you divide by 2 and you get A equals 89. So right there, it was that simple to figure out my adults is 89 tickets. And then you plug that back in and you can see that students was 203. So try this one. Your class sells a total of 64 tickets to a play. A student ticket costs $1 and an adult ticket costs $2.50. Your class collects 109 in total ticket sales. How many adult tickets did you sell and how many student tickets? Okay, so I'm going to have adult tickets and student tickets equals 64. And then an adult ticket is 2.50 times an adult, plus $1 for students equals 109. So if you notice again, both of my S's are positive. So what I'm going to do is I'm going to change the whole bottom row to negatives. So then 1A minus 2.5A is negative 1.5A equals 64 minus 109, which is negative 45. And then I divide it by negative 1.5. And you get 30. So adult tickets equals 30. So then if the adult tickets equals 30, so that would be 30 plus the student tickets has to equal 64. So then I just minus 30 from that, and I know that the students equaled 34 tickets. And then you can always double check your work, because you can do, okay, if my adult tickets, if I sold 30 at $2.50 each, that would have been $75. And then 34 tickets at $1 each would be 34. Well, 75 plus 34 is 109. So that equals perfect. Multiplying one equation. Now, here's where it comes in a little bit tricky. If I look at these two equations, it's not nice where it's like S and S. You have two different numbers for both, the 2 and the 5 and the 10 and the 3. Both of those are different values. So what you have to do if you want to do this subtraction way is you're going to multiply this whole top equation by 5. Now, I'm going to multiply it all by 5 because I want to get it to be a 10. So then I could subtract 10 minus 10 and get rid of the x's. So they already did this. They multiplied this whole equation by 5. So then they got 10x plus 25y equals negative 110. And then you're going to subtract the bottom equation. So you're minus the entire bottom equation. So then 25y minus 3y is 22y, and negative 110 minus 22 is negative 132. And then you can find your answers. So let's try this on this one, on example 3. Okay, when I look at this, 2 and 7 don't really go into each other very well. However, 15 and 5 do. So when I look at this, I want to see, okay, if I took this whole bottom equation and multiplied it by 3, then I would have a 15 right here, and those two would these two would cancel each other out. So I'm going to do that. So I'm going to rewrite my top equation. Negative 2x plus 15y equals negative 32. Now I'm going to multiply that whole bottom line by 3. So then I get 21x minus 15y equals 51. And I'm going to draw my line. And now, the 15 and the negative 15 are already opposite signs. So now I just have to add. Negative 2 plus 21x is 19x. And 32 and 51, that's a positive 51, and I'm going to minus 32 is 19. So then I divide both sides by 19. So x equals 1. Now I'm going to plug 1 in for x in the top equation, and I'm going to do negative 2 times 1 plus 15y equals negative 32. So this is negative 2 plus 15y equals negative 32. And then I'm going to add 2 to both sides. So 15y equals negative 30. Then I divide by 15, so y equals negative 2. All right, suppose your younger brother's elementary school classes sells a different brand of gift wrap, which costs $2 per package, and cards, which cost $5 per package. His class sells 220 packages in all and earns a total of $695. Find the number of each type of package sold. So you're going to start with the number that they sold. They sold 220. So they are selling gift wrap and cards. So gift wrap, I'm going to do G plus the cards equals 220. Okay? And then the gift wrap is $2 a package. So $2 for gift wrap and $5 for cards equaled $695. Now I got to try and solve this equation. Well, my G and my C are not the same in either one. So what I'm going to do is I'm going to multiply this whole top one by 2. So then I get 2G plus 2C equals 440. And then I have 2G plus 5C equals 695. So then I am going to subtract this entire top line, or you can subtract the bottom line, doesn't matter. I chose the top line because 5C minus 2C, I would get a positive 3C out of them because these cancel off. 5C minus 2C, when I combine them, I get 3C. And then 695 minus 440 is 255. And then I divide by 3. So I know my cards is 85. They sold 85 cards. So then you just do 220 minus 85. So G plus 85 equals 220. So I minus 85 from both sides, and I see that my gift wrap was 135. All right, multiplying both equations. So now, if you look at this one, the 4 and the 7 don't match up, and 2 and 3 don't match up. So now what happens is you want to end up multiplying both equations to get a common number. So if you look, they multiplied the top equation by 3 and the bottom by 2, and then that got them 6 in the middle, so they could cancel out their 6 y's. So let's try it. So try this problem. So for this one, you can choose to cancel out your x's or your y's. I am going to multiply this by 7 and this by 3. So then, and then you could do it either way, just as long as you get the same answer as me. If you did it a different way, that's totally fine. So 7 times 15 is 105x plus 21y equals 63. So I just did the whole entire top equation. Now the bottom equation is 30x plus 21y equals negative 12. I'm going to solve this. So now, in order to do this, I'm going to subtract this entire bottom line, which means you change all of the signs. If it's positive, I make it negative. If it's negative, I make it positive. So 105 minus 30 is 75x. 21y and negative 21y cancel each other out. And 63 plus 12 is 75. Works out so nicely. So x equals 1. And then I plug that back in to my original equation. 15 times 1 plus 3y equals 9. So 15 plus 3y equals 9. And then I minus 15. So 3y equals negative 6. So y is negative 2. Y is negative 2, x equals 1. All right, that's it for your notes.